All right, so now we're ready to actually start proving some identities. Now, as I go through this, I'm going to write a bunch of stuff that you might be thinking to yourself, well, I can do that in my head, or I know that, or I can skip that step, or whatever. Now, you got to remember, though, this is a proof. We are proving the identity. So when you prove something, the kind of a rule that I like to use often is, suppose you're writing this for a student that's a week or two behind you in the class. So for that student a week or two behind you in the class to understand what you're saying, you're probably going to have to explain it pretty well, pretty thoroughly for that to happen. So that's kind of the goal here. Now, in proving the identity, we're gonna do it pretty consistently throughout. We're always gonna just take a look at the identity. We're not gonna move things around from one side to the other. We're gonna take it as it is, and we're gonna pick a side. Generally speaking, we like to pick the most complicated looking side, and I think most people would agree in this example, it's the left side. So LHS, left-hand side, and I'm gonna go ahead and copy it down. So right now, all I've done is identified the side that I'm going to start with, and I'm copying it down. Now, our job is to take this left-hand side and simplify it all the way down and make it look like the right-hand side. So we're simplifying an expression here, but we know what we want to make it look like. So that's a pretty helpful idea. Now, to do this, there's a variety of ways for a lot of these problems, but this one's pretty cut and dry. You can see that in the numerator, you have these two terms, and in both of those terms, you have a cosine in common. So I'll go ahead and I'm going to factor out a cosine of x. When I factor that out, I have left a sine squared plus cosine squared, and that's all over sine of x. I also now can see that sine squared plus cosine squared, that's the fundamental identity, that's equal to 1. So then we just have cosine over sine, which happens to be cotangent of x, exactly what we were shooting for. So I'll finish this up by writing RHS. So we've had the left-hand side now matched up with the right-hand side. And again, we'll follow this technique for all of these identities by picking a side, simplifying it down, and matching it up with the other side. All right, for this one, I'll pretty much do the same thing. Start with the left-hand side because I feel like it's probably the most complicated looking. So LHS, and I'll go ahead and write it down. Again, you're not so much doing this for yourself as you are providing a detailed argument for somebody else. So we want to be really thorough with how we show this. So I've got it written down. Now, before I really get too involved here, the first thing that I would probably do is try to figure out what to do with those. I do know that cotangent is an odd function, so the negative would come out. Similar for cosecant. Cosecant's an odd function, so the negative would come out. So I'll go ahead and write this as a minus, and then negative cotan of x, and a negative cosecant of x. Okay? Now, fortunately, both of those negatives divide off, so I don't really have to pay much attention to them at this point. But moving on in the problem, remember, we're trying to match the left-hand side up with, as we simplify, this right-hand side. One of the things that I see is that I have two terms currently, but I'm only going to have one term when I finish. So it might make sense to go ahead and combine these two terms with an LCD. Now, again, we want to be really careful with our work here. My LCD would be cosecant cotangent, so I would need a cosecant of x over cosecant of x, and a cotangent of x over a cotangent of x. So again, be very, very clear on how you show that. When we put it together, we get a cosecant squared of x minus cotangent squared of x all over cosecant cotangent. And now, this numerator right here, I want to focus on it for a second. That is not one of the identities that I presented to you directly, but One of the Pythagorean identities we talked about was 1 plus cotangent squared equals cosecant squared. And so if we manipulate this just slightly by subtracting the cotangent squared to the other side, we can see that cosecant squared minus cotangent squared would just equal 1. So that whole thing equals 1. So we have now a 1 over cosecant of x, cotangent of x. And it's not a bad idea to peek back and see where we're trying to get with this. We have our cosecant already, and it looks like all I need to do is use the reciprocal identity for cotangent, flip it around, and we've hit our right-hand side. So tangent of x over cosecant of x, RHS, and we are finished with that one. All right, so the next example here, this one's a little more subjective. I don't know which side necessarily looks more complicated than the other, but I will say that I'll probably go ahead and start with the left-hand side again. And I'm going to say that because if I start with the left-hand side, the first thing that I would probably do after rewriting it is convert everything into sines and cosines. Again, you know where you're going with this, and your final result needs to be in terms of sines and cosines. So I think that's probably a little more beneficial to students, just so because they're more familiar with sines and cosines. So let's see. That'll be a sine over cosine for tangent, and a 1 over cosine for secant. I have a complex fraction now, so I'll go ahead and multiply top and bottom by the LCD of cosine of theta. And in the numerator, I'll have a negative cosine of theta. And in the denominator, I'll have sine of theta minus 1. Now, one of the things I'm going to do here is purely personal preference. I'm going to move this negative down to the bottom here and distribute it throughout that. I don't really want to lose that accidentally in my work here, so this is just something convenient I can do to make it a little easier. Now, having done that, again, it's not a bad idea to look back up at where you're going. You're trying to make it look like this, and you can see we actually have almost the opposite of that, right? We have a 1 minus sign on bottom, but a 1 plus sign on top here, and then the cosines are flipped as well. Now, with identities, a fairly common practice is that if you're stuck and you don't have anything that you need, just put it there. Just put what you need into the problem. And what I mean by that is, I want a 1 plus sine of x in my numerator. So I'm going to put a 1 plus sine of theta, and I have to do it legally. So I'll go top and bottom, 1 plus sine of theta. Remember, this guy right here by itself is an expression. The only thing you can multiply an expression by is 1 without changing what it actually represents. So our 1 is going to be sine theta plus 1 over itself. Okay, so now let's see. I will go ahead and move up here to the top of the screen. I'm going to have my cosine theta times 1 plus sine theta. There's no need to distribute that because, again, my hope is to get rid of the cosine, and it being distributed will make that much more difficult. Then in the denominator, I'm going to go ahead and multiply those together. And conveniently, those are conjugates. And not only that, but now in trig, chances are this might create an identity for us. So when I multiply these together, I get 1 minus sine squared theta, which if you look back in your notes, we know that cosine squared theta plus sine squared theta equals 1. And similar to the last problem, 1 minus sine squared would equal cosine squared. So in the denominator, we have now just a cosine squared theta. And this cosine and one of those will go away, leaving us with 1 plus sine theta over cosine theta, which is the right-hand side. All right, so as we start this last identity, it's very apparent that we're going to go ahead and start on the left-hand side again. So I'll go ahead and copy that down. And as I do this, I'll go ahead and mention to you as well that, just because you start with one side doesn't mean you can't stop momentarily and go to the other side and begin the process and then meet somewhere in the middle. So don't put so much pressure on yourself on starting on the correct side. If you get stuck, just jump ship and go to the other side and work your way down to meet somewhere in the middle. So I went ahead and copied that down. And first thing that I'd probably go ahead and look at again is this negative inside of here. Now, we've got to be real careful. This is similar to one of the U-tries you worked a little while ago. Cosecant is odd, so the negative has to come out. But because there's two of them, the double negative cancels each other out and leaves you with the same sign as you originally started. So we're going to have a secant squared x, and it's still going to be minus cosecant squared x, and then plus cosecant squared cosine squared all over cotangent squared. So again, look back in your notes of that you try when it comes to odd functions but being squared or raised to an even power. Okay, so the next thing that I'm noticing is the second and third terms. Both have cosecant squareds in them. So I'm actually going to go ahead and factor that out. I've got a secant squared x, and I'm going to factor out a negative cosecant squared x, and then I'll have a 1 minus cosine squared left over. Now, this 1 minus cosine squared from just a moment ago even, we saw that that's going to be a sine squared, secant squared x minus cosecant squared x times sine squared x over cotangent squared. And then I'll also go ahead and make the observation that cosecant squared, this is 1 over sine squared. So I've got a 1 over sine squared there and a sine squared there. Still over cotangent squared x. And again, watch how I'm showing every step here. Don't assume anything. Don't skip steps. It's not good practice to get into for proving these identities. So now the 1 over sine squared and the sine squared go away. Go ahead and move back up over here to the side. Gives us a secant squared x minus 1 over a cotangent squared x. And finally, this identity, secant squared minus 1, that is the Pythagorean identity that's just manipulated a little bit, right? A moment ago we said 1 plus tangent squared equals secant squared. Well, if we move things around, this gives us tangent squared on top. We have our cotangent squared on bottom. If I flip that around, a tangent squared and a tangent squared give us our tangent to the fourth, which is the right-hand side that we were looking to get. Now, before I end the video, I just want to say identities in general can be difficult, and it takes time, it takes practice, but the only way you'll ever get better at identities is by practicing and getting stuck. You're going to learn way more by getting stuck than you do just by watching a bunch of correct examples. So when you jump into the homework, it's okay to make mistakes. It's okay to get stuck, but it's very, very important not to give up and continue moving on because we do have several more sections of identities to go. And it's a very important concept moving forward in calculus and beyond.